Guys, welcome to the channel. This is Waga. We're going to do another Leetcode question, and the question in question is number 199, binary tree right side view, right? So what this question does, or what it is it expects you to return the rightmost values in a binary search tree, right? Binary tree, not binary search. Binary tree. Binary tree, not binary search, right? So imagine you're a person here and looking at this binary search tree. You're supposed to return the values that you can see, and the values on the right obscure the values on the left. So in this case, you will have an output of 1, 3, 4, right? But now there's one case where we should look at, right? Now imagine if this 5 here had a left child, like this 5 had a left child here. Let's say it had a 6 here. So when you come to 5 here and you look, you would see a 6. If you are standing on the right, because the 6 to the side here is not blocked by anything, it would be added to our queue because you can see it, right? The only time you can't see a value is if it's obscured by another value on the side, by a value on the right side, right? So we should consider values that are obscured like this, also part, right? Also part of our output, right? If there is no corresponding right side that could obscure it, right? So in this case, how we would solve it is, let's just go to our REPL, and we would use level order traversal, right? So let's just get rid of this. So we'd use level order traversal, and the first thing we would do is let's write our numbers, right? I don't know if I can shape it correctly. So I have we have a 1 here, and we would have let's say a 2 here, and then we would have let's go to the next line and have let's say a 5 here, and let's have 6 here, right? And afterwards we could recreate this by coming here and making this a 3, and after that coming here, and we could make this a 4, a 4, right? So we have an example tree we could use, right? So the first thing we could do is we could come here and we could have maybe q, which can be represented by q, like so, and a results array, which is going to have our results, which we are going to return, right? So we start off at the root, right? We push in the root, and we put in the root in our queue, and we could have it here. And the first thing we need to do is check whether or not the root has children, right? Now we push the root's children. We also have our results array, like so. So we include the root first, and then afterwards we check whether or not our root has children. After we push the root's children, and we need to push them in order, remember, the children, we put the left child and then the right child, right? So we put the left child and then the right child, right? So after this we push in we remove our 1, and we put it in our results queue, in our results array, like so, right? And then before we remove our 2, we check whether or not 2 has children, right? So after that we come and we check, and we do have 2 does have a child, right? So 2 has a child, and we put the child in there. And now that we have 2's child here, we can remove it from our queue, and we can come here, get rid of it, and we check, does 3 have a child? And the answer is yes. We put the child, in this case the child of 3 is going to be 4, and we remove 4 from our queue, 3 from our queue, and we put it down here. We can put it in our results array, like so, right? And then before we remove 5, we check if it has kids, a child node rather, and it terminates in 6, which is a leaf node, so we do include the child here. So we have 6 here, but we don't need 5. We remove it, and we're gonna remove the comma also, and we check, does 4 have a child? and the answer for that is 4 doesn't have a child, it's a leaf node, so we just include it in our array like so. And then we come down here to 6 and we check, does 6 have a child node? No, it's a leaf node and there is no right node obscuring it, so we could have our number here, it's going to be 6. So this would be, if we run our code, this would be our answer, and that is how the queue is going to operate. So basically, now that we have a conceptual overview of the question, we can now put it in code. The first thing we want to do is we want to create our results array, which we're going to return. So we're going to say res is going to be an empty array like so. Then we create our queue, right? And we could just call it queue, and we can get it from collection. Let's just spell it correctly. Collections.dq, and what we need to add in is the root. We start off with the root at the queue. We can't just we can't start it empty. So we can come to our loop and we check that the queue is non-empty, right? While queue, so we check if it's non-empty. We get the rightmost element and we put it in. We get the rightmost element, right? First we say right is going to be none, and then we get the length of the current queue so that you can know how many things are there. So we're going to say queue len is going to be len queue, like that, right? And after that we loop through, right, the elements currently in our queue, right? So we say for I in range, and the range that we're looking at is qlen, the length of queue, right? We first put our leftmost node. You know, we pop off nodes from the left, so we put our leftmost node, like when we start, 1 will be our leftmost node. We put it in a variable, right? So we could say node is going to be q.pop left, right? So we pop left like so. So we put it in the node, and then the node could be null, right? So we check first if it has something. We check if the node is non-null. So we say if node, and we put we assign the node to the right variable, to the variable called right, not to the right variable, but we could say right is going to be node, so we assign it there. And because we are sure that the node exists, we can now append its children, right? And remember, the order of appending is very important, right? We start with the left, right? So we say q dot append, and what we want to append is the left node dot left, and then we do the same for the right. We say q dot append, and what we want to append is the node dot right, like so, right? So we have appended the right, and then we check if our right is non-empty. So we say this needs to be outside the for loop, right? So after the for loop is done, we check if right, and after that we just put it in our results variable, right? So we say res dot append, and what we want to append is obviously the right? Actually, it's supposed to be right value, the value in the right? So after that, we should just return our array like so. So basically that. Our time complexity is going to be O of n, right? Because we loop through all the nodes in our array, in our tree rather, but then an array, right? So it's going to be O of n, and our space complexity, worst case, is also O of n, because we create a structure that might be as long as our input array. So basically that. Thank you for watching. Subscribe to the channel, and I'll see you in the next video.